Hello everyone, welcome back to my channel Multi Biomics. And before we start today's lesson, I strongly recommend that you check out the previous videos from this playlist to get prior knowledge and just where I have explained how to explore and use my Google Classroom and how the materials are organized, how you can completely self-learn this entire series step by step. Now, this series is called Computational Genomics with R, and we are following the book Computational Genomics with R by Altuna Kalil. You will find the link to the book and link to my Google Classroom, both mentioned in the video description box below. And if at any point you have doubts, questions, or confusion, you can always ask me in the comment section, post in the Google Classroom discussion, or connect with me directly on LinkedIn. So, all right, let's continue with today's lesson. Since this is the part two in the series, the first part also dealt with handling large genomics file, but let us continue with the second part. Now, here, as you can see, we'll specifically learn how to download a BD files or BED files. These are the genomic files directly into R with the help of a URL and how to load them correctly. Then we will jump upon how to save genomic data for later use and how to read large genomics or NGS files efficiently, which is very important in real world bioinformatics. So jumping into the code. So first step is downloading BD files. So let's start with it. Then this script, which you can, by the way, download from Google Classroom. So we are going to define the destination folder where all our files are going to be downloaded. So under the name dest underscore folder, you can obviously write any name. You can give any name and you can provide your file paths. And this will be acting as your parent folder, where in other subfolders, you can, according to your own, folder structure, you can download and save your files and outputs, right? Then we're going to define where the URLs will be stored. So I'm going to download two data sets, enhancers and CPGI files. This is a small subset from HG18 file. Okay, so the book follows this particular example or this particular data set. So I have also used this data set. Now let's pause for a moment to understand what data we are actually working with. Here we are defining two URLs that point to the bed files hosted on GitHub, maintained as a part of teaching material by Altuna Kalin himself. And you can see the first uh, path is for enhancer file, right? So the file contains enhancer regions from human genome. Enhancers are regulatory DNA elements that helps increase the expression of genes. They do not code for protein themselves, but they play a crucial role in gene regulation. Then the second file we are using is the subset.cpgi.ag18.bed. So this file contains CPG islands, which are region of DNA which are rich in CG dinucleotides. CPG islands are often found near gene promoters that are strongly associated with gene regulation, DNA methylation, and epigenetic control. You'll also notice the term HG18 in both file names. This refers to Human Genome Assembly 18th version, also known as NCBI Build 36. Even though newer genome builds exist today, HG18 is still widely used in teaching, benchmarking, and learning core genomics concept. The most important thing that you have to remember is that all data sets must use the same genome build to be comparable. So here, both the files are aligned to HG18. Let us also look at why we have used these two data sets. Obviously, the book is telling us to follow these data sets, but Actually, we are using enhancers and CPG islands together because they allow us to practice like reading genomic end-to-end data, comparing different genomic features, and then later performing overlap and enrichment analysis. So this combination is very commonly used in real genomics and epigenomic studies. So in summary, these two URLs gives us a subset of enhancer regions and a subset of CPG islands, both mapped to same human genome build and stored in bed format. Now that we understand the datasets, let's move on ahead and download these files directly into R. Yes, so we are now going and directly downloading it. As you can see, the environment over here is empty. Uh, First and foremost, going to set my current working directory. Let us see whether I'm currently in this directory that we have mentioned, we are going to mention or not, intended directory. The code for getting your current working directory. Okay, so I'm halfway there and let me set working directly. So the command that you're using is set wd, set working directory, and I've given the same um, path as I'm going to be assigning to my destination folder over here. You can download the script from my Google Classroom. You can make changes according to yourself. So current working directory. I hope it has changed. If I go to files, see, uh, so I have manually also located my or sorry, I've manually located my working directory. After manually also setting the working directory and checking everything in the background, I have confirmed that my working directory is set, and yeah, so let us start with executing our code. I'm going to run this. Okay. So the destination folder object where this particular file path has been stored, that is generated. And so whenever we want to give the address, this parent directory address, and we will just refer or write down this variable. Okay, and the whole path is actually stored over here. Now then we are going to give those two URLs from which we are going to download our enhancers from HG18 aligned to HG18 and the CPGI file that is aligned to same HG18 human genome. Okay, so I'm going to run this. I can see in the our environment we have got other two objects, both the URLs and the destination folders, right? Then okay, so before going any further, so what is the syntax? You just have to give under which name you're going to store the URL, and you just have to write down the you just copy and paste the URL over here inside inverted commas, and they will be directly assigned. Now, before downloading the path, you have to also mention under which local file, exact which file path, and okay, you have to provide the name, the whole path where you're going to download. Obviously, we'll be downloading in the parent folder, that is destination folder over here. So the syntax that you're going to give for enhancer file path, the command first you will use file.path, and then you'll open the bracket, the parenthesis, and here, instead of giving the whole parent directory address, you are just writing test folder, and this test underscore folder has the whole address till the data 2.data folder, right? So this is obviously my folder structure. But what you can do is you can change this, you can edit this, you can download this from my Google Classroom. Again, I'm mentioning it. Um, we will be downloading CPGI files in same way. The command we are using is file.path, and under destination folder, we are going to download it under the name subset.cpgi.18.bed. So it will be downloaded under this name and under this folder that has been mentioned in your destination folder, right? So till now we have just set which will be my parent directory, and we have given the URL and we have set the local file path. Now downloading begins, and for downloading we have to use this base R command, that is download.file, and URL, instead of URL whole address, now we can refer to this particular NC URL, which has already been defined as an object in our R environment and contains that particular URL, right? So dest file is equal to enhancer file path. So my destination file will be the enhancer file path. Here you have mentioned what is the enhancer file path, and the method for downloading is automatic. So similarly, we'll do this for CPGI file also. So let us run this and we will check whether files have been downloaded or not. So first let us check. So under the data folder, when I'm opening, the folder is empty. So after the download is complete, we could see that this file is downloaded, and I'm going to download it all together. Both want to run it. You can also press Control and enter together. Enhancer file path not found. So we have not run this particular command, I guess. I'm going to run this again. Now enhancer file path has been defined. Right. Then we are going to run this line. Okay, so download is under progress and download has been completed. And you can see these two files under the same path and with the same file name has already been downloaded. Moving on to the next section, now we are going to load these files into our R environment, and we will be loading it as a data frame, kind of a tabular form, right? So we will be first assigning this as a name as enhancer, a short form of enhancer enh.df. df stands for data frame, but you can give the name that suits best for your project workflow, right? So here we are going to use the command read.table, and the syntax is as follows. You will open a parenthesis, and then instead of giving the whole file path, we will give the object enhancer file path, which contains the whole address of that file, right? And we will tell them that the separation is not by space or not any other character, but we are using tab as a space. So this is tab delimited table. Now header is equal to false. Why false? Because when you see a BED files, they usually do not have column names. So we use header is equal to false so that the first row should not be assumed that these are header names, and so none of our data is lost. Strings as factor is equal to false. So we are going to keep the contents in the table as plain strings as text, right? And otherwise it may take as some kind of categorical data types, that's factors. Then we are going to close the parenthesis, and here by executing this code chunk, we can load the enhancer file. So you can first look at the environment. We have 1, 2, 3, 4, 5 objects. But when I run this, you see we have got a data. This is enhancer file path with 50,416 observations, right, or objects inside that. Next, we are going to load the CPGI data frame as well. I'm going to run this. So the same concept, names are different. So you can see in CPGI file, we have got 1,895 observations, right? If you want to look at them, we can just click here. You see CPGI here, and if you cross-check the PDF that I have given the link of, you can see the same data set has been loaded. You can just cross-check, and even here enhancer. So the column names are obviously assigned as V1, V2, V3. Automatically it will do. And you can see, you can just go through the structure of BD files. There will be a separate folder where I'll be explaining what these each columns mean and refer to. Just moving on. Now R automatically assigns the column name like V1, V2, and V3. So this is done by R itself. So as I've said, BD files do not have their column names assigned. So R does it for you. Now, if you just wanna look at, we have just clicked over here and we have opened a separate tab and we have already seen. But if you want to open it in the console, you can definitely type head enhancer.df or cpgi.df and we'll get the first few lines so that we can visualize it on our console. So when I run this, you can see in the console below, the first 6 lines are mentioned over here. Yeah, so the same data. We'll be discussing about what these data refer to in some other video. So if I run for CPGI, similarly, we are going to get another first top 6 lines corresponding to different columns. Okay, jumping to the next section, now we are going to write the data to the disk. Once now that you have loaded a large genomic data set, you don't want to repeat this step every time. So now we'll look at the two important ways to save data in R. Now we are going to use the save and load command. With save, we can store multiple R object into a single R.R data file. And when we use the load, objects are restored exactly as they were, including the different data types that were present inside that object, R data object. So these are great for creating project checkpoints, preserve characters, numerics, and factors data type, ideal for reproducible genomic analysis. So we can load this and then we will confirm whether our dot R data file has been generated or created or not. We are going to first use the save command and we are going to save the CPGI data frame and enhancer data frame. And under the file name, my data.rdata, right? So let's run this. The file my data has been saved, and in this my data file, the objects that have been saved is cpgi.df and enhancer.df. Right? So if I list, you can see here in my working directory, I have cpgi data frame, I have got the URL, I have got the file path, I've got the destination folder, I have got the enhancer this data frame, and then I've got enhancer URL, I've got enhancer file path in this current environment, right? So I cannot see the my data.r data. So this question will pop up in your mind. So this will never give you, this command will never give you the folders that has been created inside your current working directory. For that, you have to use the directory command, that is dir command, and in that you can see my data.rdata object has been generated, and you have got other files like bd files, right? So for the files that has been created, you have to use the directory command, that is dir command, and for listing the objects that has been defined, you have to use list command. So this is the common misconception which I also ran through in my initial learning period, that why I cannot see that our data that I have just saved and loaded. Okay. Now I'll after saving, let us load this our data into our environment, and as I run here, so it has been loaded. And with the same next times, suppose if you're again working after a few days, you can just load this object, and you'll get all the variables that you have assigned, all the R objects will as it is be loaded in your environment again. Okay. So in R, the data objects such as data frames, here the data frames are CPGI and an answer files. They can be saved to disk and reloaded later using save and load functions. And for further explanation, you can go through these comments. Now, again, if you go for listing, obviously you will not see them, but you have to use the directory command. So I'll just write over here. So this will give you the files and folders that has been uh, saved or that has been downloaded. Okay. So using the next method to save and read and load the data are save RDS. So first method was save and load function, but this is save RDS and read RDS function. The syntax is you have to write save RDS in capital and cpgi.df file is equal to cpg. So this saves the data frame cpgi.df to another file, and this is now a binary file, not a bed file. So it will be in a binary file, and that's why you can see the RDS extension. And here you have saved your CPGI data frame or the table of your CPGI file, right? Now, when you want to read this, you have to assign a variable first, and you have to write that variable, and then you have to read your data. That is cpgi.reads. So it will load your cpgi.reads binary file, but it will store it into a variable. So this is the difference between the save function and save RDS function. There you can load it directly, but here when you're loading it, you're reading the data again, you have to store it into another variable. So save RDS saves only one object. Where you load it, you must assign it to a variable. That is the difference, that is the key difference. And now let us run these commands. In this save RDS cpgi.df under the file same name cpgi but as a binary file.rds. Now when I want to load it, I'll be assigning this into a variable. Here that variable is x. You can give whatever you feel like. Now I've run this, and you can see here in the environment that another variable that is x, and it is having again the cpgi file, but it is the binary file, and it has the same number of observations as the original data frame. Just the file type is different. This is binary cpgi.rds, which has been loaded under the variable as x. Okay, so why do we use this method? Because the .rds is faster and safer. For reproducibility purposes, it is also portable for storing R object compared to keeping in plain data frame in memory or writing the plain text file. Okay, so it's better when compared to simple save and load functions. So the first part of genomic handling data is completed. Second part, we are going to deal how to read larger data. So I'll be continuing this in the same video because there's not much left. So we can use the command data.table. These are much faster, right? And larger genomic files in real life bioinformatics problem, you have got much larger files that you have to load. So these packages, will help you to load huge amount of data in a comparatively smaller time, right? So you have to first download, load this library, that is data.table. This you have to load it. So first I'm going to load this library. Okay, so data.table, and it is using 12 threads. So some information will be popped up in your console. Now I'm going to assign a variable df.f. Okay, and the under the data table you have a command fread, so that's faster read. Okay, and now you're going to read the enhancer file path, and you're naming that enhancer file path as df.f. Header is equal to false because the BD files does not have a header assigned, like the first column names, you don't have that. And then you have got data.table is equal to false. Now this data.table attribute is false because by default the fread function will return it's a different object. It will not return a data frame, but it will return a data.table object, which is different from a regular data frame. So by setting the data table as false, it will force it will force the data table package to return or to give a regular data frame object, and because it is easier for beginners to keep the output consistent with the read.table function. This avoids confusion from data.table's advanced syntax and reference-based behaviors. I'm going to run this line. And you can see I have got df.f with 50,416 observations, similar to same as enhancer file, right? So this because these files are small. Now when you compare with the load function, the other reading methods that I've given you earlier. So this for the larger files, you can see the difference in time, the loading time. So these are much faster versions. Now there's another command or the another library, that is reader or reader, you can say. First you load this. This is also faster alternative to load large genomic files. So I've loaded the library reader. And here now we are going to again assign another variable, and we'll try to load this as this enhancer files. Okay, so under the name df.f2. And the command is read underscore table. Then we are going to load the enhancer file path, and because since column names are not assigned usually in BD files, so column names is false. So this is the syntax. You can see the syntax will be different. You have to keep up with the different packages and command syntaxes, right? I'm just doing it, just giving me the column specification. There are 9 columns. So what kind of data you have, character, double, it is giving over here. And this is also much faster, the way to load big genomic files. Now, faster alternative using fread from data.table. Again, another faster alternative. These are the different file handling techniques that I'm going to give you. So the data.table library is already been loaded, and there's no need to load it again, but still I did it nonetheless. So Another data frame that you're going to be loading is under the name df underscore fast. And as we load these new objects, you can see here in our environment, these will be loading. So here the fast alternative is fread. Okay, enhancer file path, header is false, data.table. So this is another way, another syntax. You can do it like this also using fread again. It's just a redundancy in my script, I guess. So using read underscore table from reader, it's a good choice if you already use the tidyverse, used dplyr or ggplot2. Okay. Um, it, which environment you prefer? That is your choice. I've given you different types, different packages and commands. So library reader we are going to load, and again we are going to use read underscore table, and we are going to load it under the name df underscore fast too. Yeah, it's the same, and the way of writing is just different. I hope you understood the whole script. It is relatively easier. If you have followed the previous video, you could have done it much faster. You can download this from my Google Classroom. You can directly message me in the LinkedIn if you have got any doubt. I know that this video has been a little slower. Pardon me, because in winters I usually don't feel better, and this is the reason why my videos, the frequency of uploading is very less. But I'll try to upload more videos faster in the future. To summarize today's lesson, um, we have downloaded BD files or bed files directly into R, and then we have loaded them correctly. We have saved our data for reuse, and different methods we have used. So these are some of the file handling techniques, large genomic files. So not only BD files, there are other genomic files that you can also load using these functions. Um, in next video, we will come up with some other topic. Usually, I'm planning to upload plotting in R using base graphics. So the script is already ready, as you can see over here. We'll have fun now. It will be a colorful session. I hope you'll enjoy it. Yeah, that's it for today. Take care.